everyone, welcome back to Exploring the Coast with Hannah. We are now on week 2 of our climate change series, and on this week's episode we're going to be looking at sea level rise and zonation changes among rocky intertidal species. Let's go.
So what causes sea level rise? Sea level rise is caused primarily by two factors related to global warming: the added water from melting ice sheets and glaciers, and the expansion of seawater as it warms. Global sea level versus relative local sea level. Just as the surface of the Earth is not flat, the surface of the oceans is also not flat, and this sea surface is not changing at the same rate globally. For instance, it is known that absolute water level height is higher along the west coast of the United States than the east coast. Global sea level means the average height of all the Earth's oceans. Relative local sea level refers to the height of the water as measured along the coast relative to a specific point on land. So, how much is global sea level rising? According to the National Oceanic and Atmospheric Administration, global sea level is rising at an average rate of 3 millimeters per year. Sea level intermediate projections for California estimate sea level will rise approximately 1 meter by year 2100. So how much has sea level risen in Monterey? The relative sea level trend is 1.71 millimeters per year, which was based on monthly mean sea level data taken from 1973 to 2019. This graph also shows projections of how much sea level could rise here in Monterey to the year 2100. If we look at the intermediate to intermediate high estimates, it shows that sea level could rise here in Monterey anywhere from 1 to 1.5 meters. Sea level doesn't rise at the same rate everywhere. For instance, in areas of the northern Gulf of Mexico, like Louisiana pictured on the left-hand side, are showing significant subsidence where relative sea level trends reflect an increase of greater than 10 millimeters per year. Alaska, on the other hand, is showing a decrease in relative sea level because the region is dominated by isostatic rebound, or regional uplift of the land caused by the retreat of glaciers. Before we discuss the potential zonation shifts of some rocky intertidal species due to sea level rise, I wanted to go over the 4 zones of the rocky intertidal. The first one is the splash zone, which mostly consists of bare rock, with occasionally having some barnacles, limpets, or snails inhabiting that zone. The high zone area is mostly for small shelled animals like limpets, barnacles, and crabs that can withstand long periods of exposure to the air. The mid-zone area is mostly inhabited by mussels. They have adapted to withstand intense wave action by holding themselves on rocks. The low zone area of the rocky intertidal mainly consists of soft-bodied animals like sea anemones and sea stars. So what are some of the threats rocky intertidal species are facing due to rising sea levels? The first one is habitat loss. It could also change the abundance and distribution of many intertidal species. It could also increase the predation of many species within the rocky intertidal. It could also cause a drastic change in food webs among rocky intertidal habitats. Here are a few intertidal species found here on the California coast that are most likely to shift zones due to sea level rise. They include green pincushion alga, iridescent algae, mussels, and honeycomb tubeworms. Because it is a high intertidal zone indicator species, green pincushion alga is most likely to shift zones upwards towards shore due to sea level rise. A main factor is because it competes with other algae and several marine invertebrates. It is in fact such a fierce competitor that it effectively smothers sessile invertebrates such as mussels and barnacles by growing on top of them. Iridescent algae is also another algal species most likely to shift zones due to sea level rise because it is a mid and low zone indicator species as well as a dominant competitor. Sea mussels are also very likely to shift zones due to the fact that they are the most dominant competitor of the mid-zone area and form very dense beds, which provide habitat for many algal and invertebrate species. However, if these mussels are left unchecked, they can take over other species' habitats. Honeycomb tubeworms are likely to shift zones since they are a major low to mid-zone species indicator and competitor. These polychaete worms live in tubes of cemented sand grains. The worms cement their individual tubes on the sides of one another and can build dense reefs up to 6 feet in length. While there are limited long-term data sets to demonstrate climate impacts on zonation, intertidal zones, as well as the animals and algae within these zones, are predicted to shift shoreward in response to rising sea levels. Second, rising temperatures could compress the entire intertidal zone, making it more narrow. As temperatures rise, heat-sensitive intertidal organisms will not be able to spend as much time out of water and therefore will make it too hot for them to survive. We hope in the future that we are able to gather more data to get a more conclusive idea of just how climate change and sea level rise will impact these rocky intertidal habitats. Thank you so much for joining me today. The next video in our climate change series for Exploring the Coast with Hannah will drop Tuesday, July 7th at 11 a.m. on the Pacific Grove Museum of Natural History's website on the Museum to You page.